Wait, we're recording. So each note, let me go big screen. Boom, isn't that so nice? Each note should have the title and it should have the date. Yeah, that's the thing. What we're going to do is we're just going to summarize all the things that we have to study for the test. Okay? So Unit 2, again, this is the Grade 10 IGCSE Computer Science. We have hardware. Okay? And then we also have software. These are the topics. Hardware. What you need to know in hardware is you should be able to identify all the pieces of a computer. Okay? You need to be able to identify all hardware and its functions. For example, we have storage. Okay, we have primary and secondary. We have RAM, ROM. Okay, then we have hard drive, right? We have SSD. We have CD, which is optical. What else do we have? About storage. Oh, we have the cloud, the 网络 cloud. Okay? So you need to be able to know what all these things do. We also have the CPU. Okay? In the CPU, you need to know about also there's the bus system. And then in there we have, inside the CPU, we have the von Neumann. I don't know how to spell his name. Von Neumann architecture. And the different registers. Let me think. Was there any other hardware we studied? You should know the different parts there. This is the majority. Okay? So this is about hardware. And I will review this. These are just the topics. The second thing that you need to know is about software. Okay? So in the software, you should know the system software, and then the application, right? And an important one there is the operating system. Okay? What else do we study? Can you look in your notes? Did you do any logic gates or anything? Everything from this is unit 1, we're from unit 2. I think that's most everything, right? Yes. Okay. So these are the topics. Now we're going to go into more detail about the hardware and software, things like that. Okay? So, hardware. The key hardware, I'm going to talk about the storage is the key hardware. Okay, and the CPU. These are really important topics there. And we also have to be able to identify all that good stuff. So I'm going to scroll down. Is that okay? Again, this is all on the team. So if you ever lose this, you can go onto Teams and it's going to be the last file here, okay? So again, all the PowerPoint and the homework here, parts of the computer, okay? These will have all our PowerPoints, primary story, secondary story, system requirements, CPU architecture there, okay? So that's where we are. And at the very bottom, we have Unit 2 review. So this is where we are. Okay. So those are the topics. Let's talk about hardware. I'm just going to see if I just, can I, okay, right here. Storage. So storage is composed of two storage. We have primary, and then we have secondary. Okay? And this is the hardware. Primary has two pieces. Do you know the two pieces of primary storage? Yes. We have RAM, and then we have ROM. Okay? Now, in here, you need to know some key differences between RAM and ROM. What is the other word for RAM? Is it volatile or non-volatile? Volatile. Yes. So right here, this is called volatile. What does volatile mean? This is non-volatile. Volatile. Sorry, this is A. Okay? Volatile. Okay. So, volatile means what? Say one more time.
No power, no data.
Yes, no power, no data. And this means that when there's no power, all data is lost. Okay?
You wrote volatile last time is V-O-L-I-T-I.
Volatile. Yeah, so I think the correct spelling, let me just erase it so we can see more clearly. Okay. Volatile. Volatile? I think. Volatile? We will have to just double check, okay? It's either the I or the AI. Sometimes I get it mixed up. So volatile means when it has no power, all the data gets lost. Non-volatile means it's saved, even when no power, okay? It's basically saved. Now, we need to talk about RAM. What is RAM? What is its function? This is what a stick of RAM looks like. What is RAM?
Loading.
Yeah. For example, we have 2 GB. Basically, what RAM is, it stands for random access memory. Right? And his function, if I were to compare them, it is used for loading programs. and he's close to the CPU, okay? You'll notice that the RAM is right here. It's close to the CPU because the CPU needs a place to work, okay? So we have the CPU right here. This is my CPU. And the CPU is the processor. And there's going to be some wires that connect to my RAM. These wires are called what? What are these wires called? Do you remember? Yes, this is called the bus system. It's called the bus. Okay? And the computers these days are 64x. What does 64x mean? We have like 32x. Any idea what that means? This is the number of lines that we have. Okay? It's the size of the bus. That's correct. And so this is 64-bit bus. That means that we can send 64 bits at one time. We can send 60, and we call this a word. And so if your bus system is really big, like 64, that's one word. One word, this means how much data can be sent on the bus, okay? But we'll talk more about that later. I'm just giving you a picture about where we are. Right now we're talking about what is this RAM's job. Now, it's for loading programs. It's also for temporary storage, right? So after you have that, the CPU needs a place for storage. Temporary storage. Okay, that's why it's under a primary storage category. Okay, it does save the thing temporarily when you load the program. His most important thing, what is the most important program that we put in storage? When your computer first starts, what is loaded into the RAM? What data? What is there's different type of software. What does OS stand for? OS software. What is OS software? OS stands for operating system. Operating system. Okay? So the operating system, is a software. We have 3 types of operating systems. What kind of computer do you have? Okay, we have Windows. Okay, tell me other operating system. We have Linux. And one more. We have the Apple, it's called iOS. Or Mac. Mac, iOS. Okay? So, what operating system is the most popular? What one's the most popular? What one's the most popular? Actually, in the world, Windows is the most. Okay? Why? It's because it's cheap. And it's good for business. Right? Linux. What is Linux? It's that little penguin, right? What is Linux? It is free. It's free. It's open source. Open source means that they give you the code. You can actually customize Linux. Okay? And then iOS, people that use iOS, it looks nice, right? And it's easy to use. It's easy. Their whole theme is easy to use. Okay? But it is more expensive. That's why it's not as popular as these two. Okay, the smallest one is Linux, okay? But it's growing. It's about, I don't know, a couple percent of the world's operating systems there. Okay, these are all, it belongs to system software. Do you remember how we have different software? And so there's different categories, but the most important one is the operating system. Okay? So in the RAM, why am I talking about this? Is because when your computer first starts, we have the RAM. Let me draw green, just to symbolize RAM. Usually RAM's green, right? The very first program that's loaded into RAM is what? What is the very first program that's loaded into RAM? Yeah. When your computer first starts, there's a logo that shows. Either it shows a window logo, or it shows you the Linux logo, or it shows you the Apple logo. What is that? It's a company logo of your operating system, right? Where is that? What is the computer doing? Where is it putting that? Where is it loading the information? The operating system is going where? From your hard drive to where? The CPU needs to work. He needs a table or somewhere to work. So he puts it where? Yeah. Where's the screen data go to? Yes. All the things that I'm drawing on the screen are where? They're in RAM. And so when your computer first runs, it loads this thing. And we call that, when your computer first starts up, we call that booting. Do you know what booting is? Booting is a process where the computer looks through the BIOS in the ROM. We'll talk about that briefly, but it's going to see everything's okay, and then the Windows logo starts, and then it takes some time. Does your computer take time to start up? Why does it take time? It's because we have a hard drive, and there's a certain sectors there where the OS is stored. You can't write over. This is read only. And then what's going to happen is it's going to copy it into RAM. And then let's say I open up Word or something like that, or I play a game, it's going to put this into RAM. Can your RAM ever get too full? Can your RAM get full? Yeah, because if you have 2 gigabytes, this is the size. And if your RAM gets full, what's going to happen? It'll become very slow. It's because we have to swap in and out. And when we're swapping programs in and out, there's a thing called thrashing, where the computer becomes slow because he has to work by taking the information out and putting it on the hard drive, and from the hard drive back into RAM and vice versa. Okay? So this is to do with software. Now, so this is the most important thing inside your computer for RAM. Okay, we're going to continue on with this. Why is the OS system so important? Tell me some things that the operating system does for me. Operating system. What does he do? Look in your notes. What are some functions of the operating system? Yes, very good.
security. Interface.
Okay. OS system, operating system. Let's write down 4 things he does. Say one of the things that you were telling me. What does he do?
Manage RAM.
Yes, his job is to manage the RAM. Is it full? If so, he will have to store some into the hard drive and swap in and out. Okay, very good. Tell me something else.
Multitasking.
Yes, it's used for loading different programmings. Okay, it's used for multitasking. Okay, for loading more than one loading programs. Okay, you will go into a long time ago it was MS-DOS, but now you can just click. Okay, what else does it give you?
Manage pairing links.
Yes, it's file management. File management. Very good. What else? One more.
Storage.
They manage the storage. Oh, but we got the file management. I'll just put in here storage. Tell me something else.
Security.
It's used for security, yes. It has credentials. When you first load Windows, you put a MIMA, right? Sometimes you have a password. It's for security. Security.
And interface.
Yes, and also a GUI. GUI is a interface. It gives you the mouse, the keyboard, and something that you can have there. So operating systems, you need to know this. Operating system is star. Okay, 4 marks. Okay, you need to at least know 4 or more. The more the better. Okay, so that goes into the RAM. Okay, I think RAM is pretty good there. We also have virtual memory. If your RAM, I just want to briefly talk. If I add more RAM, what happens to my computer?
It won't be quick.
It will though. If I have only 2 gigabytes of RAM, but I increase the RAM, what is going to happen to my computer? Yeah, the speed at which it can load will increase. But there's a little graph because will the speed indefinitely go higher? If I add more RAM, this is RAM, the speed should go up, right? But what happens over time is there's a point where the amount of RAM does not increase. Oh, something's funny. I need to reverse these to my graph here. This should be speed. This should be speed. And this is the RAM increase, right? So there's a point where it doesn't help me. Why? There's a point when adding too much. For example, if I added 64 gigabytes of RAM, do you think it's going to help me? There's going to be a point it doesn't help me. Why?
Because it is full enough.
Yeah, it's because RAM only gives you space. It's like storage for loading programs. So if your RAM is full, buying more RAM will increase speed, right? So I have my OS system, I have my Photoshop, whatever. And if it's full, we get slow. Why does it get slow? Is because we have to go from RAM to the hard drive. We have to swap in this thing called thrashing. Thrashing. Thrashing is when we're copying between hard drive and RAM. We're swapping the data. This thrashing makes me slow. And so adding more will help me. But if I have too much, if I have a RAM that is only this full, and I'm never going to get 64 gigabytes of, to need, and this is all empty, increasing the amount will not increase the speed. Agree? So there's a limit to how much RAM you need to have. Right now, based on your everyday use, if you're doing games or Photoshop, usually about 32 gigabytes is kind of like the normal laptop that you buy today. But as technology increases, the programs get bigger, right? And so it goes higher. So therefore, in the future, having 64 gigabytes of RAM will be beneficial. Cool? RAM okay? So that was a good summary of RAM. Now we're going to talk about ROM. What is ROM? Tell me, what is ROM? What does ROM stand for?
ROM stands for read-only memory.
Yes. Read-only memory. Can I change the ROM? Can ROM change? Can I change ROM? What do you think? It says read only, right? But in fact, it can change. But we don't change him too much. Okay? Now, what is the function of ROM? What does he do? What does ROM do?
Measurables like file, SDI.
Yes. He's used for booting the computer. Booting means like to start. Okay? Booting is basically start. Starting. There's some things that we have to do. Booting is when we load the operating system. Okay? And it's when we check everything's okay. And this is called, it holds the BIOS. Okay, I'm just gonna move this this bar. I don't know if this bar can move. Yeah, I'm just gonna move it over here. Does it move? I'm still learning how to do that. I don't know. Okay. What does it hold again? Oh, it holds the BIOS. And what the BIOS is, it's a small software program that checks that everything. It says, and it stands for Basic Input Output System. Tell me an input to the computer. You should know some basic input. Tell me input device.
Keyboard.
The keyboard. And so it's going to check, do I have a keyboard? If I don't have a keyboard, will my computer run?
Yeah.
No. He will say, missing keyboard, please use a keyboard. If I don't have a mouse, will my computer run? It will run because you don't need a mouse. Maybe you just type, okay? So if I don't have a mouse, he doesn't check really the mouse, he checks keyboard, okay? Keyboard's the most important input, he's gonna check that, okay? So if you don't have a keyboard on a desktop, he'll say, missing keyboard. Please add it, okay? Output, tell me an output. An output device for your computer.
Output, printer.
Yeah. So he will look, okay, do I have a printer? What else?
Audio.
Yeah, he'll look, okay, do I have audio card? Do I have a screen? If I don't have a screen or something like that, okay. So he's going to check. We have this thing called power on self check. He's going to check all this stuff. And also in here, we have the system time. The ROM has the system time. You know the time of your computer, it actually saves it to the ROM. And so every time you boot your computer, you see it tells you the time. Can I change the system time on my computer? Can you change the time of your computer? Yes. And so it says read only is because we only change the time once a year, right? Some countries, they change the time on the New Year's, right? Not on the New Year's. That's the calendar. They change it during the time savings. Or if you go to another country, you can also change, okay? And that information is stored into the ROM. Also, the drivers. Do you know what a driver is? Do you know what drivers are? Drivers are small programs that allow us to talk to hardware, okay? Drivers are there. It's basically, what a driver is a program that tells my computer how to talk to the device. It's a program that tells the PC how to communicate with the hardware. Okay. I think that's everything for ROM. Did I miss anything? Okay, so ROM is done. Okay, so we did primary. What is the other word for primary? Primary storage. There's another word for primary, wasn't it?
Basic.
Basic memory?
I don't know.
Primary memory? I think there was a word. I can't remember. Anyways, if I think about it, I'll let you know. Primary storage. Yeah, I don't quite remember. Okay, now we're on secondary storage. What is secondary storage? Yeah. I'm trying to think how to organize this. Where can I move my notes? We're gonna move over here. Is that okay?
Yeah.
Well, going over here. Okay. We have multiple. Tell me some secondary storage devices.
HDD.
Yes, we have HDD. What else do we have?
SSD.
We have SSD, solid state drive. Yes. What else do we have?
USB and CD.
Yeah, we have like external things like USB, thumb drive. What was the other one? CD drive, CDs, and we also have the cloud, right? Online. Okay? You should know the differences between all these hardware. Okay? You should know the difference of all these hardware. These are secondary storage. What is secondary volatile or non-volatile data? When I turn off the computer and the hard drive, is the data lost? No. Volatile or non-volatile?
No.
Correct. All these are non-volatile. Okay. I wonder if there's a short, how to move it. I'm not sure if there's a shorthand thing for doing this. It's kind of fun playing around, eh? This bar is always in my way. All right, let me throw you over here. Right here. Huh? Oh, it's on the bottom. Oh, genius. Okay, so this is non. I have to change my size of my thingamajig. Non-volatile. I think this is not working for me. Need to zoom in. Non-volatile. Can you Google, can you just double check? Volatile. Volatile or volatile?
Volatile. I think
Have a look. Volatile. Okay, let me just delete this. Okay, this is volatile. No, it can't be. Think volatile. Anyways. Okay, it's non-volatile. That means it's the data is saved on there. Okay, so hard drive. How does the hard drive work? Inside the hard drive, we have these things. What are these things called?
wait, I only have adjective.
Volatile. Oh, that's correct. Volatile. It's A-T-I-L-E. Yeah, okay, I was straight. V-O-L-A-T-I-L-E. Volatile. Okay? So that's the correct spelling. Volatile. So, do you remember this there, Carol? What are these things called? Inside your hard drive, we watched the animation, right? What are those circular disks inside the hard drive? These are called platters. And these platters, they have metal oxide. Basically, they're made from metal oxide. This is, metal oxide is like oxidation, sorry, it's like it's a reaction, right? And what happens is we have a little head, and he can change the property, and he can write on the platter and change the metal oxide. Okay? So what is that called when I write to the platter? I'm writing it as it's spinning. We have this thing called RPM. He's spinning super fast. as he rotates, I can write to him. And if I change the metal oxide, what is this called? This is called a track. A track is a line of data. A line of data on the platter. Okay? Now, if I have a whole program, I can write a whole area. What is the area called? It's called a sector. Okay? So, if I have an area of tracks, this is called a sector. Okay? And the problem with these old hard drives is sometimes these sectors are not connected. Maybe I have a piece of program here and here and here. And so we have this system software called defragmentation or defrag. Okay? Defragment. Defragment is a utility tool. It's a system software. It's a system software to speed up my computer. What it will do is it'll take these different tracks and it will move him to one location. And so that the read-write head doesn't have to go as far. Okay? So this is an old hard drive. It would just randomly save the data onto the platters. And once in a while, after deleting and writing, you had to run this utility tool called defragment. Defrag is for short. If you just put defrag, and it would copy the tracks into sectors, and therefore it would speed up my computer. Okay, so there's other system software as well, like utility tools like antivirus checker and stuff like that. But it's on the older hard drives. Okay, what is this guy called again? This blue line. What is this? The thing that writes the data. What is this guy's name? He has a little arm. And then what is this right here? Gerber, right? And this is called it's called a read write head. It's tato, and that's what it was used. And it would change the metal oxide onto the platter, and then you could write it. There's some problems with these things is it uses lots of power. It has to spin really fast. What happens if you drop this hard drive? What do you think is going to happen? If you drop this hard drive, or you drop this computer and it has, it will break because it's a mechanical. Right now, do the computers use the hard disk drive? No. Right now, we don't have. We have the small. Where's the hard drive in this?
Oh, no.
Do you know where the hard drive is? This is the hard drive. And that goes into the second one. So hard drive, done. Hard disk drive, can we check it? Now we're on SSD. Your computer is, we have SSD and then PCIe. Okay? So, let me go down. Second one is the SSD. What does the SSD stand for? What is SSD? I'm going to try to zoom in. I like to zoom in because then it gives me the lines. I like lines. but then it's gonna mess up my rating. I wonder. It's fine. All right, let's move it over here. SSD, yes, stands for solid state drive. And for short, it's called SATA. Okay? What a solid state drive is, it's just a very thin thing right there. And we watched the video. Do you remember we watched the video about it? It has these little black chips on it. And these chips are called NAND. Okay? NAND, what is NAND? These are electrical devices. It's an AND gate, but it's not an AND gate. Okay, it's a logic thing. Okay, and so it uses electricity. It uses these things called transistors. Right? NAND. Yeah, it's NAND, not AND. Do AND? N. NAND. So inside your computer, you have a gate, drain, and sink. You have this three-pronged device that looks like this. And these are called transistors. And what a transistor is basically a switch. It's an electrical switch where you can have a 1 or 0. And basically all logic gates are composed, all computers, if you put a whole bunch of them together, we can create these logic gates, like the and or not. And if we put a whole bunch together and put them in different layers, we can actually use that to store data. Okay? So these transistors, they actually have a layer, and they use some doping where you have some positive electrons and negative electrons, right? And then right here we have a gate. Okay? And we can control the flow of electrons. Okay? We can, it's basically neutral. Okay, we have an area that's neutral, and then we can control on or off. Okay, that's called a transistor. And so there's no moving parts. Okay? There's no moving parts. There's no moving parts. That's good. It's a little bit more expensive. Okay? But it's okay because they're getting really cheap. Almost all the, solid state drives is very popular. It's called SATA hard drives. And they had a little xian. Okay? What is the newer ones now? We even have a newer one because the issue with these guys is 那个线. It was a serial communication. The xian only had like a couple wires in there. It wasn't very fast. There's actually a faster one. And that's what this computer has. It's called a PCIe hard drive. PCIe is even smaller. It's a little shell Yiquan. And he connects right onto the bus. Do you remember how we talked about the bus system? How we have a 64-bit bus? He doesn't use a wire. The SSD and the hard drive, they used a wire to connect to the MUBAD, to the motherboard, right? But the PCI, peripheral card interface, look, see, he doesn't use a wire. He actually connects right to the bus. So all computers now, they're using mostly this. And it's called NVMe, and he's fast because he connects right to the CPU. We don't have to have a CN. Okay, so that's the most modern one. It's called PCIe, and he's similar to the solid state drive, but the difference is he had no wire. It's the fastest that we have so far, and it connects directly to the bus. Okay? And so he'll be able to send the data super fast. But he is the most expensive. He needs the most money. Okay? These are the laptops and stuff today. It's called PCIe. Cool. Now, tell me, do we have any other ones? We have USB CD. Tell me about the CD. We did a presentation, I think, right? What is, now we have some, this is all inside your hard drive. We have some external storage. What is the other word for external? Do you know? Other word for external is called, starts with a P. Peripheral. Okay? Peripheral means 在外面. Okay? Or external. It just means you have your CPU case, right? You have your MUBAN, you have your motherboard, right? Motherboard. And then you have your case of your right? And then you have your CPU and all that, and your RAM. This is a CPU, and that's your RAM. We can attach external things. For example, you could put a USB disk drive. Okay? The USB is outside the PC, right? For example, right here. You see this right here? This is called a peripheral device where you can put it here and then you can call it out. So this is called external storage. Or the old ones, the old computers, they had a CD-ROM, where you could put a CD. Do you remember what a CD is? And what the CD is, inside the CD-ROM, you had some light. And you could burn some holes like this. Where, do you remember the name? Those holes are called what?
Pits.
They're called pits. And the smooth part was called a land. I forgot. Was the pits zeros or one or something like that?
Yeah.
Pits was a 0 or 1?
Pit was what?
A pit was a 1 binary and a land was a 0. And the other word for CD-ROM was called optical disk drive. Okay? It just means CD. CD for short. and you could take out the CD and you could put it into your CD-ROM. Your case would have a little hole, and then it would come out. I remember the days. Probably your dad knows, or your parents know. Before the old computers, right on the very front, they had a disk drive right here, and you press a button, the tray would come out, you put the CD in, and put it in. Maybe there's some old cars that have that as well. Okay. And then the last thing, what was the last thing? We have USB. What was the other storage? Yeah. Today, the most modern type is we have a cloud, but the cloud is basically the internet. Right? Cloud storage. What is cloud storage? If I save my stuff on OneDrive or Google Drive, or Baidu has some sort of drive as well, where is that? If I save online, where is it saved to? If I option onto the internet, where does it go? Is there in the heaven? Is there a big hard drive in the cloud?
No.
Where is this hard drive? When you 保存 on the 网络去哪儿？天堂？ Where is it? Yes, the cloud, the internet is made from big computers, powerful computers called servers. We have these big computers called a server. And in here, we have a whole bunch of HDD, hard drive. Sorry, this should say HDD. HDD. And sometimes they have the old technology, sometimes they have the SATA drives. And they have a whole bunch of farms. We call this like a server farm. Okay, if you have a whole bunch of hard drive, we call these a farm. You're a noming. It's called a server farm. And all your internet, when you save on the internet, it's stored on here. And it also stored over here. And it's stored over here. And it's called RAID, where if one of the hard drives goes bad, all the data is saved in pieces. And so, is it safe to save your data on the internet? If you put your pictures on the internet, is it safe?
No.
It's actually pretty safe. Unless the building gets blown up with a bomb or catch on fire, right? Because even if one hard drive dies, will you lose the pictures on the internet? Let's say on TikTok, on YouTube. If one of the hard drives, this happens all the time. If one hard drive dies, it has the data to replicate that on multiple other hard drives, and it'll just copy over a new hard drive. And then they're going to fix this. They'll fix that, no problem. So it's pretty safe. It's convenient. It's safe. You will not lose your data, right? Because it's on the internet. What is something very bad about it? What is bad about it?
Need money.
Yeah, okay. You need money. Tell me something else that's bad about online storage. It's 方便, right? The good thing about it is I can go anywhere. I can go home and I can still watch my videos. I can be anywhere. But something bad.
Maybe some people use it.
Yes. It may not be too safe, where maybe it's privacy. Maybe there's a hacker. A hacker breaks into the server farm, and this happens quite often. That you may not know, but there's been lots of data breaches where people get into Google, people get into the file hackers, and then they can steal your MIMA, right? And your photos and stuff like that. So some farms are more secure than others, but if it's not too important information, you can put it onto the internet. If you work for the government, should you save your things to the cloud? Should the government save data to the cloud?
No.
No, it's probably not too safe because the hacker can steal the important information. Cool. That's everything about the software, hardware about that. Now, the last thing that we studied was CPU. Is that correct? You're okay?
Bigger the cloud.
Yeah. The cloud is the internet. It's a server. Servers are basically big desktop computers that have a whole bunch of racks of hard drives, and they usually use some like old technology because they're cheap, right? And then if a hard drive goes bad, they just swap it out. The last thing that we'll do is CPU. We have to talk about the CPU, and that's the last topic.
Okay.
Very good. Wait. Last topic about the hardware software is CPU. Okay, let me see if I can get these lines looking nice. Ooh, nice. I can get the lines. I can just go like that. Interesting. Ooh, so big. Okay. So CPU. Ooh, so fat. CPU. What is CPU? Central Processing Unit. Right? Now, in the CPU, this is what your CPU. Inside him, we can cut them up into, we can have more than one CPU called cores. We can have 1 core, 2 core, 3 cores, 4 cores. The cores just means that I can multitask. I can open up 2 programs at the same time and then do 4 calculations at the same time. Okay? So we have cores, and cores can also be broken up into smaller components called threads. Okay? Cores is just basically a CPU within a CPU. Core is equal to a CPU in a CPU. Okay, it's like having 2 brains. And we also have CPU speed. CPU speed is measured in gigahertz. And it's basically how fast that the CPU works. A CPU can only do three things. Do you know the CPU cycle? Do you remember? The CPU cycle?
Oh, yeah.
It can it can fetch, we decode, and then we do the thing, execute. Right, this is called the CPU cycle. This is called CPU cycle. Okay? And in there, we have the so fat. We have the von Neumann architecture. von Neumann. And it's basically how the CPU works. Inside your RAM, we have the address of the data. And then in here we can have instructions. And we can also have data. For example, I have move to. I have LDD4. And then I have 2, 5, 4, 10, 20. And then in here we have the ACC and stuff like that. Okay. So basically, the von Neumann architecture is when. Say one more time. This you can just put an arrow for around for something. So, how does this work? Well, we actually, inside the CPU, we have some different registers. Okay? So inside your CPU, we actually have different things inside him. We have the control register. We have the arithmetic logic unit. We have an accumulator. We have these different things inside your CPU. We have these things called registers. And what registers are is inside your CPU. We have some small RAM. We have some small location, like the ACC is a small storage. Okay. What a register is, it's a fast RAM inside the CPU. And there's a total of 5 or 6 registers. Okay? You need a register to save this is called the address. The digit, right? And then right here, you have some data, you have some instructions, and we also have some data. These are also data. That's also data. We have some data. Okay? So these address, they have some registers like 变量. It's like a variable. And I'll put a different color. Maybe I can choose blue. Blue's not very good. Let me do pink. This is called the memory address register. Yes. Memory address register is called the MAR. The MAR saves the digit. And then this kind of data, we save it into the memory data register. He's also a guy that saves some data. And then we have the accumulator. This is the other piece of data. And we also have a program counter that counts 1, 2, 3, 4. We have this thing called a PC, program counter. Okay? And then we also have an instruction register. It's called the CIR. Okay? So we have 1, 2, 3, 4, 5. We have 5 registers. Okay? We have, and basically the steps. How does the computer work? Step 1. Are you ready? So we have 5 registers. The very first thing is in the cycle fetch, decode, execute. The very first thing is the program counter is going to be equal to the program counter plus 1. Every cycle through the CPU cycle, the PC is going to first point to the very first memory location in RAM. And what does this mean? Actually, it plus 1, it means it's going to go to the next address. So the next address is saved to the PC. Program counter. This keeps track of where am I in the program. Okay? The next thing is the PC is going to, number 2, the memory address register, the address of the program counter is going to save into the address. So whatever the program counter is pointing to, the next instruction is for, it's going to load it into a BLL called the memory address register. Okay? So the second step is the address is saved to the MAR. MAR. What does MAR stand for? Memory address register. And the address will be some sort of hex number, okay? So an address looks like this. 0 is a hexadecimal like F2 or something like that. This is what an address looks like. It's not data, it's just a location of the data, right? Because if I look back here, 1, 2, 3, 4, these are the locations. And those locations in RAM are saved as the digit. Okay, so we got the memory address. Now, you'll notice that at a specific location, sometimes I have data, and sometimes I have some instruction with some data. Okay, and this is called opcode. Okay? And so the third thing is we need to save the data. This is called data. And then the data has 2 things. Maybe it has a move to. It has some data and it has some instruction. We need to we need to save this somewhere. Okay? So this is the third thing. Is boom. The memory data register is what we're going to do is we're going to save the current data in memory. Okay. The data plus instruction in RAM. So it's going to save the data and instruction. Number 4, we have this other biela called the CIR. The CIR is going to take the instructions. So instructions we can have is add, subtract, move. This is going to go into the CIR. It's going to save the current instruction. What does the CPU have to do? And then what the CPU is going to do is going to execute. Step number 5 is called the accumulator. The computer is going to 计算. It's going to do the execution of what it has to do. It's going to store the result of the instruction or the command. Ooh. Okay? And that is basically the von Neumann architecture. Have a look. We did some homework about that. Remember how we added 1 and 1 and stuff when we went through the RAM? And then that's it. Okay, cool. I know this is a lot. Now you're up to speed. And then you can watch this online and self-study. So let me just save here. Control Shift